Okay guys, look at the ladies and guys, look at the bottom down there. Those are my columns. Now let's come up to the top. Let's have a little fun. Alright, we'll get to this possibly another video, but these are your columns. As you can see, column. Zoom in, you can see it in print as I pull away. Zoom in on that. Okay, so this is a piece of canvas. That piece of canvas on top of there. That was going to be used on this, but now, I don't know. So these are our critical shear areas around here, right? Critical shear areas. And what we're going to do is we're going to give an idea. So let's, there's our column. There's our column. Here's our column. Column. This doesn't have to be that critical on that for your column detail. I have one offset here. We'll get to it. This is why I want you guys to see me do the columns first. If I want to make sure it stays offset. Okay, yeah, that's my offset one, right. I'll move it to there. Okay. So now we have our columns. That's just our columns yet. And now we are going to have our tributary areas between there. Let's see if I can grab some cat food. I leave the cat food out on the porch for the critters. Okay, so now you see the cat food. Now we're going to come down here with the vehicle. Alright, vehicle puts on brakes. You see it surge, you see the fabric surge down. Of course, the concrete is not supposed to do that. But it's cycling. It is a surge. If there's any type of wobbling like that, there's a surge taking place. And you can imagine that this is sharp here. It starts pulling on it over the many cycles. It can only do so much. This tributary area looks a little different than the rest, doesn't it? So let's give this some critical shear protection. Let's give it some protection to help you conceive it. Let's give this one some protection. We'll go in the same plane. This is the simplistic version of it. And now, the tributary area is here, right? Tributary area is between it. From here to here. Let's make sure you're zoomed in. You can see what's going on here. Okay, I guess I have to tilt that up a little bit. Give me a second. So I need to tie that in, right? You need to tie in the two areas. So I need to tie. I need it so this doesn't deflect. The deflection is very minimal. So you run your reinforcement, tying it into this side, right? Tying it in. Now I'm going to just tie it in without overlapping. I'm not going to go down this side. I'm just going to tie in this one area alone. So now you can see if the steel was here, between here, it's going, if you try to pull down on this steel, it's engaged in there. It's locked in the concrete. Remember the concrete? I showed you how it locks it in. It freezes it. It won't be two pieces of metal two pieces acting. It'll be a single piece. So it won't be two pieces able to do that because they'll be locked in with concrete around them, surrounding it. So they'll act as one piece. And so there's your tributary area going into your critical shear area, right? Now, the amount, it does matter. Here's your column. Let's say the detail like that. That's the head of the column, that's the base. So in our situation, we have a little bit of cover here, concrete, and then there's a stamp, the pavers on top, or they call them pavers, right? And I call them tile or whatever the hell they look like there. But this was the original build. So this was about, I'm guessing, around about 4 inches of concrete. And then right about here we have the rabbit ears come up. And then there's about another layer of 4 inches. And then below that is the balance. Let's just say the balance. It's out to 9 inches. So I screwed that up, didn't I? Screwed that up. So that would only give us about an inch below that. Let's just try that though. Let's go 1.5 inches. It gives us 9.5 inches. Because I think there's about 4 inches here, so whatever is below there. So here's our concrete in here. That's whatever this little bit of rabbit ears that's turned up. So this distance is what matters. It gets added. You can add it to the top. This little bit there, depending that those rabbit ears. Those are the rabbit ears, right? Yep. You can make sure you can see it. Or have steel connecting them all the way from here to here. So we need our steel connecting so we can tie it into, so it can transfer down to into the column. Of course, you have an issue because the column is now this deck, this lower part of the deck, below the 4 inches, are being held by. You see how the rabbit ears stick out, and that would be another shear zone for it, or shear zone right there, where the steel is side mounted to it. And we see that by the pool deck where they only have that little bit of head, and then you see the remaining. This is where I make this drawing from, this type of detail from. This is the pure cap, and so pure cap, and then they have pilings underneath to hold this up. There is no sinking going on here, and they got rebar for the deck, for the floor in the garage area. But hopefully this helps you understand that tributary area, how this rebar needs to be tied into there. And we're not talking about tying in with wire ties, we're locking in with concrete. And as it cycles though, this is the area that breaks free. Here and here. This is the area that breaks free when we see our failure, our punch shearing. So let me just do some lines here. Let's add it into this zone over here. I'm freehanding, obviously, and let's go ahead and tie that in a bit with some cross rebar. So you see the cross reinforcement is out here also, reaching it. Let me zoom in for you a bit. Or lift up on the camera a bit and try that. Okay, so now you have good view. It is almost 100 degrees today. So now we have this going on. So you see how we're going to tie the 4 of these together. And we're just going to use this area here. And I'm going to really be kind of rough on this. And we'll tie, well, it looks like it's off a little bit, but how awesome is that? Well, is it on an angle? I'm gonna show you that's an angle back to there. But it's not on an angle. Okay, so you see this one on an angle. But they didn't run the rebar on an angle to get it over to there. they ran it parallel. So you can see that once we get so far out down the deck that it had to get back to here, this area's got to be extended. The critical shear area has to be extended to be able to grab this reinforcement here between this one and, okay, I got to zoom out on that, and the next one. No, we're good. No, we're not. Here we go. Between this one and this one. So now we have this almost like a, and there's offsets. Remember there are offsets everywhere? The column now offset. Now we're back at it again. We're just not getting to the critical shear areas in a clean fashion. We're like clipping them, and most of the torque is on one side here. On this one, as you see the reinforcement going across, you can go two directions with this, right? So let's just say they had it in two directions. So as it's loading here, this steel going in this direction is the one that's going to help you. The steel going this direction is going to stop with the deflection as it loads this direction. If a car was to load, the tires to load on this one, it now helps in that direction, two directions if it's right about there. Once it gets out to here, and let's say this tire here and here are points, you can start seeing it now pulling, if you can imagine, surging into from our tributary area into our puncture area, and it starts working on that area. It starts working on it to the point where it's no longer, it separates the steel. The steel, it's holding to some degree. But I think in this case we have a deck delamination. So let me see if I can void this for you. Make a void. Take a little liberty here. So here's our column. This one goes all the way up. Alright, to the second floor. It's our lobby level. It's also the not lobby level, it's the garage floor level right here. Garage floor. Which is actually also our garage floor is also our garage floor is also our pool deck area at one point when you get closer to the pool deck. This is that steel that goes in here. I don't know if it goes all the way through across. Let's say it goes through. It doesn't matter. That's the steel. So that would be the steel we see here. It goes into this deck, and I made that little notch, but it doesn't, and then there's rebar that comes across this direction, right? So that would be the rebar coming this direction, or you can prick your poison and go the other direction. It works either way. As the cars load here, there's our tires. As it keeps loading on here by this column, it loosens this area here. Becomes loose. It breaks its holding power. It only has a limited amount of concrete here above this. So that's cycling. There's that little bit of concrete. I'm going to make another big exaggeration of it. That rebar that's out of here is inside here. You can see that it's not much to fracture it. And the rest of this can fall down because there's no reinforcement, lower reinforcement in some of that area. Some of it they do put some lower reinforcement in, and some of it they do not. So you can imagine that issue. Now, notice how when I push on here, it's not really affecting out here. Where's my little toy, my thing there? And this one here. So your tributary areas, even though I have a lot of tension in here, when I push here, you can see it graph now. You can see how it graphs. It's kind of on the line there, and then pulling here, here, and here. So You can see it now, but it's not moving. The nuggets out there, the little squares. So I can push here, but it's got some deflection out there, but it's not moving as much. Oh, I know. Give me a second. Bring it down to this view. The neighbor dropped me off some fruits. All right, so now you can see it better, right? See the gap under there? Coughing. Coughing. Now, I'm not saying it's making out there at all, but I'm helping you understand how tributary areas matter and how you don't want that deflection. It's cycling around our columns, really stressing our puncture design, stressing it. You don't want it to, you want it to be greater than that. Now, they only required 40 pounds per square foot of live load on this deck. I don't know how that works, because a car is going to create more than 40 pounds per square foot when it comes to a stop. I see other people doing calculations and they do the full division here to here. Well, that's not the way it works. It's point loading. And they said 40 pounds per square foot. That is a point load. They didn't say 40 pounds, 400 pounds per 10 square feet. And that's what everybody interprets it as. No, it's 40 pounds per square foot. After that, you're excessively loading the deck. And that's it. I mean, there is no magic beyond that. So there we are again. Just wanted to show you. So you can try to add that up and say this area here is loading onto there. Well, actually I'd have to go further up. And then I'd have to come here, and this would be the area, the tributary area loading towards this direction. Did I get that right? Let's see a photo if you can see it. Yeah, you can see it. Let me zoom up a little bit. So now you see that, like I said, it's at 800 degrees, I think, right now. So now you see the area around our critical shear zone is out to here. So your car's coming here, backing up, loading, stopping, surging each side of that column. Rocking it, and it's slowly working it. It's slowly working the top of this area here and I'll show you another video where we see this, where I can explain this failure. And I've talked to you about it before, but now you're getting drawings. I'm going to give you some hard, more like this, more physical images, so you can start seeing it, so you can start seeing the reactions much better. So as you can see, as I press between over here, this one would be this way, right? So theoretically, when I press on this side, all the load's supposed to come over here. Of course, that doesn't work that way. It still stresses onto this side, but the load is considered to be carried by this, which is ridiculous. But that's just ridiculous. It's not a cantilever. This wasn't designed as a cantilever. So I don't know how engineers can state that the load should be considered to be carried by this column. Unless it was designed as a cantilever, it's still carried by both columns. Even though I'm on this side of it, it's still stressing here. It's just that simple. Unless it's designed as a cantilever to do that, and the cantilever here, this center section, if you load it, will be carrying, it's transferring the stresses to wherever it is. Because they're not designed in cantilever. They're designed to just, try to stay flat, put the load back down the column without punching a hole through it. Without punching a hole through it. As you can see, this fabric it's in tension now. It can take a lot of beating. It takes a big profile. Let me get you down a little closer for it. Let's take a look at that. You can see how the head is showing. And then you see the stress right here. It goes up on a ramp, if you will, right about there. Well, I guess I need to see, what side is that? Right here. See that ramp up? That ramp up is how we see it, some of the materials, when they break. This deck deflects like that, and it tears down. When it tears down, we see the materials in that little profile. Yeah, I can rotate. I set this up on a wheel system, so I've got more to do with this display for you guys. But now it ramps up. Now you can see the profile of the deck like this, and then we have materials bent on it. Some of them broke free, fractured so abruptly, acutely, that just went straight down without rubbing against the column. Some went down and rubbed against the column as they did it, so it fought a little bit. And where it had less steel to stick out here into this area to allow it to break free and just flat back over. So there's our critical puncture area. And I just want to show you the fabric. It's pretty damn tough. It's in tension. Your clothes, your shirts and all that, this is fabric. It's in tension. Tension is pretty strong. So the puncturing is not going to be instant, just like with our product. Now, I think I'll end this video with that, and I'll try to get you, I will get you something else that's kind of cool. Should I do it in this video? I'll get you something that's kind of cool. Let's do that. Let's go on. Let's give you a bonus. If you were a guy, you know what kind of bonus I'm talking about. All right, so bonus is obviously one sheet of paper, punch through. Okay, we'll keep that paper, but we'll move it off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sheets. 11 sheets of paper. Now this would be the equivalent to the head. What's so important about the head of the head being over there for your puncture protection. Now you can see that. There we go. It took a lot to get through there. Again, one sheet, no big deal. So now we got 12 sheets, and that's only one extra sheet. And I'm really focusing it. You know, that's not fair because because obviously I should load it, differently. And I think that's fair about now. So, one sheet, 11 sheets. It took me really leaning into it to do it. You see the puncturing though? You see what took place there? You can even see the flaps as it slides down. Hopefully that helps you see what's going on there. One sheet compared to 11 sheets, and you can imagine I were to fold this over and attempt it. I might not get anywhere. That's 24 sheets. So your concrete cover on top of your heads matter. That's how part of your shear protection. Puncture protection is the thickness of the head. But you got to keep that head together. You got to keep it together. You can't have it fracturing and breaking apart. Rebar helps do that. We can't have it cycling out here like that and then expect this to stay integral with the column. And we see that it doesn't stay integral with the column, that the deck itself. The column stays status quo, but the deck itself drops down. Hopefully this video will be helpful. I'm going to load this up.